Hi ladies and gentlemen, in this video we are going to be looking at ionic compounds and we're going to be learning how to write formulas. So you'll want to have your flow chart with you and you'll also want to have your periodic table. Okay, so let's look at our first example. We have calcium sulfide. Okay, so if we look at our flow chart, we have to look up our element symbols and then we want to find their charge. So if I find calcium on the periodic table, the symbol is Ca, and I find its charge because it's in group 2. And I know that all of my elements that are in group 2 will have a positive 2 charge. All right, then I'm going to go and I'm going to look at sulfur. Now I know it says sulfide, but that's because we changed the ending to IDE. So this is really sulfur. So I'm going to look on the right side of the periodic table for my nonmetal, which is S. I know the charge is going to be S minus 2, because if I find sulfur right here, I see its charge is minus 2. When I go to write my formula for calcium sulfide, what I'm going to do is I'm going to do the crisscross method. So if I have calcium at positive 2 and sulfur at negative 2, when I crisscross those charges, meaning I take this 2 and put it underneath calcium here, and I take this 2 and put it underneath sulfide here, I can see that those two 2's are going to cancel each other out. So my formula is just going to be CaS. So anytime you have charges that are the same, but that are opposite for an ionic compound, you just cancel them out. All right, so we can see down here, we're going to have that same thing happen when we do silver with chlorine, because they both have the same number. So that's why when we combine them, there's no subscript. It's just AgCl. Okay, let's go ahead and look at the next example. Sodium phosphide. So I'm going to write the symbol for my element, which is the metal. Sodium is an alkali metal, that's why it's positive 1. And then I'm going to find phosphorus, which we changed to the ending to IDE. So let's go ahead and take a look at our periodic table. Here's sodium, group 1, positive 1 charge. Then I'm going to go and find phosphorus. Phosphorus is right here in group 5, and it has a negative 3 charge. So these have different charges. So now when I want to make my formula, I need to do the crisscross method. So this positive 1 is going to crisscross and it's going to drop below the P. This negative 3 is going to crisscross and drop right below my Na. So I have the formula Na3P. Now notice when you're writing your formulas, you're not bringing down the positives or the negatives. You are just bringing down the number. Also notice that we are not writing the number 1. We don't have to use that because we can see that we have 1 atom of P. All right, let's look at the next example. Here we have silver chloride. So I'm going to look up my symbols, I'm going to find the charge, and then I can crisscross and reduce if necessary. So silver is a transition metal and its charge is positive 1. Chlorine is a halogen and its charge is negative 1. Now something to notice with silver is it is a transition metal. However, it can only have a charge of positive 1, so we don't have to try to figure out what its charge is. In another example, I'm going to show you how to do that. So then we're just going to take our two elements and we're going to combine them because they have the same charge, just opposite signs. So it's going to be AgCl. Now it is important that you write the metal first. You do not want to write SCA or PNA. It has to be the metal first and then the nonmetal. All right, let's look at this next example. It's a little bit different. This one is magnesium phosphate. Okay, so what you'll probably see is that this is a different ending. It ends in ATE All of these other ones have ended in "ide." Okay, so that means it's going to be a polyatomic ion. Okay, but I'm going to follow my flow chart. It says to look up the symbols and then find their charge. Magnesium is in group 2. Here's magnesium, +2. Then I have to find phosphate. Now, phosphate is not the same as phosphorus, which changes to phosphide. You have to, again, look at the 8. If I have anything that ends in 8 or "ite," you need to be looking at your polyatomic ions, which are on the back side of your periodic table. So here I'm going to go and find phosphate, which is right here. So PO4 -3. So I'm going to write my symbol and my charge. Now, when you have your polyatomic ions, I would strongly encourage you to just put parentheses around the P and around the O so you don't move that 4. Now that I have my formulas and I have my charges, I'm going to do my crisscross. So I'm going to take the 2 and I'm going to swap it and put it outside of the outside of the phosphate. And then I'm going to take this -3 and I'm going to drop it right below my magnesium. So looking at my formula, I have Mg3. The 3 came from right there. Parentheses, PO4, close my parentheses, and then I have that 2 that came from my magnesium. All right, and a way that you can double check it is all of your ionic compounds have to balance by charges. So if I have 3 magnesiums, that's going to give me an overall +6 charge because each magnesium is a +2. So that would be a +6 on my left side. If I look on the right side, I have 2 phosphates. Each phosphate is -3. So that gives me a -6. So those charges will neutralize each other out, +6, -6. So that's how we know we wrote our formula correct. All right, we have one more to do. Titanium, parentheses, 4 chloride. Now, this parentheses is telling me that titanium has a +4 charge. You can look at your flow chart to understand that this number means 4. Okay, so on your flow chart, we're giving you all of your Roman numerals 1 through 10, so you can figure out that the V is 5. So if there's that 1 and then the V, that means it's 4. So titanium is a transition metal. It's right here. We can see it doesn't have a charge. That's why we had to use the parentheses with the Roman numeral. So that is titanium. And then the other element in our formula here is chlorine, and chlorine is a halogen. It's over here, so it is a -1 charge. So when I go to write my formula for titanium 4 chloride, I'm going to take these charges, I'm going to crisscross those charges, and I get TiCl4. And again, to double check, chlorine has a -1 charge, so that means my right side is going to have an overall -4 charge, and then titanium is +4. That's why there's only one of them.